Hello guys, welcome back to my channel. We all know that we are currently in the computer network playlist, and today's video we are going to talk about very interesting topic, that is network devices. Everyone should understand about the network devices and also should understand how those devices are connected in the real time. Please make sure that watch the video till the end. By the end of this video, you will clearly understand how they are connected and how they are working in the real time. Okay, in the previous videos we discussed the history of internet, the types of networks and network topologies. But to make all of that possible, we need network devices. Without these devices, the data wouldn't be able to travel from one place to another place. That's how critical they are. Okay, let me take one example and try to understand the importance of the network devices. Imagine you are writing a letter to your friend. You have written your letter and you have posted your letter in your village post box. Since your friend lives in another village, this letter has to travel many villages. Now, the postman of your village take your letter and give it to the post box of the next village. Then the next village of the postman take your letter, send it to the next one. At finally, your friend's village postman take your letter and deliver to your friend. This is how postal system works, right? Now, if there was no postal system here, how would your letter ever reach to your friend? In the same way, if there was no network devices, your data would be stuck at one device and would never travel to anywhere. Okay, that's how important these devices are. Okay, now we are going to discuss the following network devices are, and also we'll cover few outdated devices that were commonly used in the past. Okay, we'll start with access point, then switch, then router, then gateway, and finally modem. And also we'll cover few outdated devices by the end of the video. Okay, instead of simply explaining each device one by one, let's take a real example to understand how these devices work together. The example is, imagine you are sitting at your office. You're trying to access a website. To access this website, your request has to go through many devices, right? So what we will do, then I will break down the each device in order the data passes through, and also explain the device the role in this journey. Okay, so this will help you to understand not only the what are the devices are, but also how they actually works in the real world scenarios. Okay, we continue with that example. You go to your office, you open your laptop and search for something on the Google. Now your laptop send the request to the Wi-Fi. Okay, so the Wi-Fi comes from the access point. Okay, here's the thing we need to discuss about the access point device. What is access point? Let's look at the definition of the access point. A access point is a device that allows other device to connect to network wirelessly instead of using physical cable. This is the definition. In simple terms, if we can say that access point provide the internet access to the device over a Wi-Fi without the need of wired connection. So it acts as a bridge between the wireless devices and the wired LAN. So if you look at the image, that's how access point device looks like. Okay, that's all about the access point. Now this access point is connected to a switch. What is switch? It is very important to understand, and this question is frequently asked in the interviews. Please be focused on it. Okay, so look at the definition of the switch. Switch is a network device that operates at LAN level. If you don't know about the network types, please watch my previous video that where I explained everything about the network types. Okay, so now see the function of the switch. The main job of the switch is to enable the communication between the device inside the same LAN. But here the key part. Unlike older devices like hubs, switch does not broadcast the data to all the devices. Instead, it sends the data only to the intended device based on the something called MAC address. Okay, I know that you are feel bit confused, so that's why I will take one example and put it in simple way. Imagine you are sitting in your office Okay, the particular request go to the access point, then access point is connected to the switch. Now what we will do, there is a switch. Okay, there are group of computers connected to a switch. Okay, this is A computer, B computer, C and D. If A want to send a message or an email to the D, the request will go to the switch. What switch will do, instead of sending this message to all the devices, switch will check the MAC address of the destination computer. Okay, once it checks, it will send the message to the only the D. Okay, so this is how switch works. It does not send the message to the, all the devices, whatever the device connected to the switch. Okay, don't worry if you don't know the what is MAC address. We will cover that later in the TCP/IP protocol video. For now, just remember, switch is a smart device that makes communication possible within a LAN, and it happens efficiently, securely by using MAC address. But nowadays, we are also seeing the layer 3 switch in many networks. Okay, these modern switches, especially in big networks, have started including layer 3 capabilities. What does it mean? Which means they can perform routing as well, just like a router. So, in simple terms, if we can differentiate between the layer 2 and layer 2 switch forward the traffic within the same network using MAC address. It will use MAC address. Layer 3 switch can also forward the traffic between the different networks by using IP address, just like a router. Okay, so that's all about the switch. Then the request we are discussing, example, the person is accessing a website. So now the request gets forwarded from switch to the router. Any guess why we are forwarding this request to the router? The reason is website is a part of different network, not the same LAN. If we request to the other network, we need to forward the request from switch to the router. So now what router do with that request? Before we understand that, first understand what is router. Okay, router is a device that connects multiple different networks. Now you might wonder what is different network here. Let's understand. LAN is a considered one network. When you want to send a request to device outside your LAN to accessing a website which is hosted somewhere else, that website part of different network, right? In this case, the router come into the picture. It helps forward your request from LAN to the other network. For example, over the internet. Okay, if you don't fully understand the different networks right now, don't worry, we will talk more about in the upcoming videos related to IP networking. For now, just remember this, router handles the communication between the different networks by using IP address. So whenever you try to access IP address that is not present in your LAN, so switch forward the request to the router. The router take care of reaching the external IP. So this is what router does. That's why router is a key device in any network setup. Here also we have one more interview question. The difference between the switch and router. Then let's see the difference. Okay, the primary difference is that switch connect device within the same network. Router connects different networks. Then switch works at layer 2. Router work at layer 3 of the OSI model. If you don't know about the OSI model, don't worry, we will cover in the next video. Switch uses MAC address to forward frames. Route uses IP address to forward packets. This is all about the difference between the switch and router. Okay, now the router send out the request to the gateway. So what is gateway here and what does it do? So let's look at the definition of the gateway. Gateway is a device that helps translate between two different networks that use different communication protocols. Since not all the networks speak same language or follow the same standards. Let's imagine one network speak one language and one network speak a different language. So now the gateway job is to convert or translate the data from one protocol to another protocol so the communication can happen smoothly. For more understand, let's take a real world example. Imagine one person speaks Chinese and other speaks Hindi. If they want to talk, they need a translator, right? So the translator makes sure that both understand each other even though they speak different language. In the same way, A gateway acts as a translator between two different types of networks or systems. In this example, you are requesting from private LAN using certain set of protocols. When your request reaches the gateway, it translates into the format that other external networks like internet or cloud service that can understand. But most of the people get confused between gateway and the router. Here is the quick summary. Router helps you to connect two different networks. Gateway not only connect the networks but also translate the data when they speak different protocols. That is the key difference. Actually, you can check the gateway IP in your PC. Okay, let me go to terminal. Since I am using Mac, the command is route-n get default. See, here is the gateway IP. If you are using Windows, you can use ipconfig. Okay, so this is all about the gateway. Okay, once the gateway translates the data will be sent out to the modem. Okay, what is modem here? Why do we need modem? Are we using modem right now? Modem is a device used to convert digital signal to analog signals and vice versa. First, let's understand the difference between the digital signals and analog signals. Okay, let me take into physics. First, we will see the definition of analog signal. Analog signal that change smoothly and continuously like a wave that can have any value at the moment, any moment. Useful for traditional radio systems and old telephone based internet. We all know that digital signals, how our computers and laptops store and communication data, the form of binaries, zeros, ones. So, when the digital data from your computer need to be sent over analog signals, like analog lines, like old telephone lines. So, the model converts into the analog signals. When receiving, it converts analog back to the digital. But nowadays, we are not using analog modems much because modern networks like a fiber, cable or DSL already carrying the digital signals. So modems were mainly useful for traditional radio systems, old telephone based internet or early TVs. Okay, then the modem sends the request to the ISP. So the ISP takes the request across the internet to reach your specific web server you are trying to access to. Finally, we reach the server. Once the server processes your request, it sends the response back following the same path in reverse. So this is how all the network devices work together when you request something on the internet. Alright, okay, let's quickly recap how data flows through the network devices when you make an internet request. First, your device connects to the internet through an access point, which provides wireless access to your network. The access point is connected to a switch, which helps devise the same LAN communication by using MAC address. Then the switch sends the data to the router, which decides how to forward the data outside the local network to other networks using IP address. If the destination network uses different protocol, then router forwards the request to the gateway, which translates the protocol so both the network can understand each other. Now the gateway passes the request to the modem, which traditionally convert digital signals to analog so they can travel over older lines. Now the modem sends the request to the ISP, the company that connects your internet. Finally, the ISP routes the request to the web server where your website hosted. Once the web server responds, the data travels back to the same device in the reverse order, all the way to your screen. That's the complete journey your data takes through the network devices. I hope this breakdown helps you to clearly understand what each network device does and why they are important. As I mentioned earlier, we will also touch some outdated network devices that were commonly used in the past. Okay, this includes hub, repeater and bridge. Okay, let's go through them one by one. Now we will talk about hub. Let's look at the definition of the hub. Hub is a basic network device. It allows multiple devices to connect within the local area network. However, hubs use broadcast communication, meaning when one device sends a message, it is sent to all the connected device. This is not only creating unnecessary traffic but also compromise security and efficiency. Because of these limitations, hubs have been replaced by the switches, which are more smarter and more efficient. Okay, now we will see about the repeater. Repeater is a used to amplify or regenerate weak signal to extend the range of network that were commonly used in the wired networks or early Wi-Fi setups. However, in modern networks, we use Wi-Fi extender or mesh system, which is not only boost the signals but also adjust power and coverage intelligently based on the devices and network needs. Okay, this is all about the repeater. And finally, bridge. Let's look at the definition of the bridge. Bridge used to connect two separate LAN segments, allowing them to function as single network. It is also helped filter based on the MAC address. And today, these functions are handled by the network switches with the VLAN supporters and routers. Okay, so this is all about the legacy devices. That's it for today's video. I hope you have clear understanding of network devices and how they work together in the real time. I will see you in the next video with another exciting topic. Until then, take care and bye bye.